So this video is for 1.1, um, 1.1 material, which is about particulate matter. I did ask you to look over bring your study guide with you. So this is what we're going to be doing, using the study guide to explain the situation. Um, so let's get started. Page one of it. So particulate matter, nature of matter. Now, this part is actually a lot of it is review, either from grade 10 or from previous years. So you've learned all this before, different elements and the relative mass. In terms of naming of compounds and things like that, chemical nomenclature, it is a given. Atomic, polyatomic ions, which one is which and what's are their charge, again, that's a given. Now, the different mixtures. Again, some of you were saying, oh, you learned this back in grade 6 or 7. And you know what? That's a lot of times that's when this material is covered. So when you're talking about pure substance versus mixture, pure substance, you're talking about things that are the same type of particles, either atoms or molecules. And then you have mixtures. When you have mixtures, you are talking about, do you have a different, do you see only one phase? If it is, that's homogeneous mixture. Basically, you're talking about a solution, salt water. Heterogeneous will be, you have different layers. And so this is the part where the separation technique matters. If it is homogeneous, a lot of times you have to do distillation or drying the things out. Heterogeneous, yes, that's what you pronounce. Heterogeneous mixtures, sand and water, things like that, you can do filtration or decantation. That'll be a way to separate the two things. The states of matter, okay? You should know all the names between, as well as how are the particles like. So as you can see, basically between each stage, solid state, the particles are close together. They're not really moving. They are vibrating, but that's about it. Liquid state, they're vibrating, and they also can actually rotate too. But at the same time, during gaseous phase, they can do all sorts of stuff. They can vibrate, rotate, and translate, basically going random straight line motions. Now, this is a part where we talk about the heating curve. Now, the heating curve is this part here where between each, during the phase change, so melting and boiling, or when you have condensation, when you go the opposite direction, condensation, or freezing, these temperatures are staying at basically during that time, temperature is not changing, but it is basically the particles itself, as it says, the intermolecular forces are being loosened up or being overcome if you're going from solid to liquid or liquid to gas. The heat energy is used to break apart these intermolecular forces. Okay, so that's why the temperature is not increasing. So that's page one. Now, part of page three. Now, this part here, properties of chemical reaction. You guys learned this. Chemical equation, which part of it it is. If you look at it, you all learned this before. The coefficient and mole ratio, that's like about balancing equation. Now, ionic equation, we haven't really quite covered that part, but you will learn how to balance ionic equations later on in this course. Don't worry too much about that part, okay? And let me just look at that. And page 6, blah, blah, blah. Page 6 here. Now, titration, things like that, don't worry about titrations. But the atom economy. The atom economy, that's the only part where there's a calculation. Essentially is we're trying to figure out, based on the particular reaction, like this example here, aluminum and iron oxide, and you're producing no, aluminum and iron oxide, giving you iron and aluminum oxide. Let's just say you want to get iron. Okay, your desired product is your iron. So in this case, what you do is find the total mass of desired product. So you're talking about mass as in atomic mass. So let's see. Yeah. So total mass of the desired product, as it says here, because it has two Fe. Fe iron atomic mass is 55.85. Two times that will give you this. Now divided by total mass of all the product. You want to see out of all the product, how much is the iron? So you have to add the iron, which is 2 times 55.85 plus Al2O3. This is the atomic mass of aluminum, 26.8 times 2 plus oxygen is 16. So since there's 3 of it, so it's 3 of that. That gives you the total mass. So the atom economy is the mass of iron, 111.7 divided by 213.66. That will give you 52%. Okay, so it is giving you what the whole point of it is, assuming this reaction is going perfectly. Your machine is working, people know what they're doing. What will be in some ways, like how good is this reaction to do what you want to do? As it says, it is for industrial process. Okay, because we're not even talking about practical yield yet. So this is what the atom economy is about. So let's look at some practice test question and see which one of it relate to 1.1. So that's a practice test, the page 2 from Blackboard. So if you look at it, first one here, calculate atom economy. That's pretty much right there. Now make sure you show your work and make sure you show the correct units in your calculations. Zooming through, I actually have it on paper to jot down the notes, but I wasn't able to use the document camera. So question number 7. Okay. No, that's 11.1. Question number 8. Okay. So this part here about how to separate the different mixtures, that is also about the whole how do you solve this particular question. This is also the part about different states of matter, homogeneous mixtures, and things like that. So how are you supposed to separate them? Okay. And that's about it. That's the part on the practice test that's based on 1.1. So why don't you pause this right now, try to do this question, and then we'll go over it. I'll go over it with you. Okay. So press pause right now, and we'll try it, and then I'll go look at it together. Okay. So now I assume that you have finished your questions. Now let's look at the answer. So question 1, in terms of the atom economy, so mass of useful product divided by mass of the reactants. So this question was about the atom economy, because the atom economy was about you want to make ammonia. So in this case, you're talking about the useful product would be, going back to 1 here, ammonia, which is NH3. So you have 2 nitrogen and 6 hydrogen. So this calculation here, 3 hydrogen, you have, now this, it should be a typo because this should be a 2, not a 3. Yeah, this is a typo. 2, yeah, This is a typo here. It is a 2. However, if you think about it, 28 plus 6 gives you 34. So this is definitely a typo here. Divided by the total mass of all of it. So you have to account for the nitrate, the ammonia, as well as the H2SO4. So that's part about them. Okay, that's a 2 nitrogen. You have how many hydrogen? You have 6 hydrogen here plus 2, so that's 8 plus the 32, that's sulfur. And then you have O4, so you have 4 oxygen. Okay, so you plug this in the calculator, you have 25.79. So that's what it is. And which question again? Is 1.1. 1.1 has question number 8. Okay, so question number 8, you have oil and water. So you're using a separatory funnel. That's a way of decantation. So let's quickly look that up. Separatory funnel. So separatory funnel, that's this thing here. When you pour the oil and water into this container, you can actually see a layer in between. This diagram is better. So in this case, you can see the water will be sitting on the bottom and oil always floating on top, and then you just let the water drain, and then you can just separate it that way. Okay. So you're talking about separatory funnel. And then the other one is evaporation or crystallization. That's a soluble solid, so salt and water. So evaporation or distillation would work. Crystallization, that's how you form the salt afterwards. So that's it based on the practice test about 1.1. 1.1, as we see on the review guide, it is very simple. So look over the material, and if there's any question, ask me. Okay? Good luck. Move on to another station, either 2.1 or 11.1 or whatever. Okay? Good luck. Let's see.